The other news is, last time I'm talking about universities are checking prerequisites and courses. And the answer I got back was that for the university to actually kick students out of classes because they don't have the prerequisites, the departments have to put a request in to go up that level, and we haven't done that. Particularly for the graduate level, it's like, how are you going to check? I mean, because most graduate students don't take undergraduate courses here, how do you check that you've taken it? For every student, right? Yeah. Yeah, I would probably consider retiring then if they asked me. I mean, do you want to spend 2 weeks just going through and say, based upon the title of a course, is equivalent to that course? Yeah. The CSU campuses are pretty independent, so don't know. I don't have any immediate plans to retire. Um, so last time we ended up talking about model view controller, um, and right, and let's see, there is a new pattern called the Elm architecture, um, which basically the view is what they call virtual. So on the website, each time you display the view, you create a new DOM structure, then display that. Um, and the idea is that, yeah, you do everything in functions. And so your view is created by functions. So every time you want to change it, you recreate the entire view. Um, that's sort of a radical change. You start to see React doing this. And Flutter does the same sort of thing. And that's the influence of reactive programming, where we're going to we have a data store, and when something changes, that triggers an update on the view and reconstruct the entire thing. But there's web patterns. Some of them you're familiar with. Let's see, the template view. If you've done any PHP work, right? Or Java server pages, it's all the same thing, right? In terms of you embed inside your HTML commands, which are then interpreted in your language, right? So, we start embedding special tags, which then are pre-processed before you execute that in your language, and that's PHP, right? And Java server pages, and there are a number of different templating systems out there. And yeah, it's great. I mean, so graphic designers can generate the page, and then you just plug in the pieces you need, right? The logic or the data you need to insert into that page. but it often becomes a mess, right? As you get more and more pieces, how do you structure your code when it's all embedded in little pieces everywhere, right? And how do you prevent repeating code here and here and here? It becomes hard to deal with. And then in Java server pages, you create libraries, which Java server page libraries, as you call, in the other pages, and it just becomes this. HTML files are not designed to structure code, right? Yeah, so example that I ran across doing this 2 weeks ago. So if the master's exams, right? You all know about master's exams, and you probably sort of might be vaguely aware that the department changed rules a little bit. And the rule is if you sign up for an exam and don't show up, then you can't take the exam the next time it's offered. I would say out of 120 exam slots over all exams, there were times when you'd be 50 slots that don't show up. Yes. And we then have to, I mean, it's a big pain because you then we produce packets, right? And for each student, there's a packet, and you want that packet to be anonymous, except we have to pass it out to make sure it's the right student, and they take the name off of it. And the staff goes nuts because exams are always offered at the beginning of the semester, and they're very busy, and it's hard to get, the instructors will never get the exams in on time. And so there have been times when like 5 minutes before the exam is supposed to start, we're still stuffing things in packets, right? But the problem related here is, okay, so there's the website where students sign up for exams, and the website was developed by undergraduate students, actually undergraduate students from Brazil. And now you want that website, when your student goes there, you don't want them to be able to register for exam they signed up for last time but didn't show up for, right? Yeah, yeah, we got the history, right? So we got the history. That's our problem. The problem is you now to put the logic gets embedded in this template, right? But the problem is there's like several conditions. One is if you can take the exam at most 3 times. If it tries something the 4th time, you won't let them do that, right? And so all of a sudden it's like, oh, I need a case statement. If, right? Oh, but there's no case statement in the template language. Okay, I know, I'll nest if statements. No, you can't do that because the template language didn't allow it, right? Because the template language, you start doing these if things, and it has to interpret it, and they didn't consider it. You want to embed if statements instead of if statements. And so, yeah, there's oh yeah, it's all mentioned in the database, and you extract it, but you need to display it, right? And when you want to display, here's the exams you can sign up for. You don't want them to allow. You don't want to say you want that grayed out or something to say, okay, you can't take this, and why you can't take it, right? And so that becomes a display thing, right? So the database. Yeah. That's easy. That's the easy part. The hard part is you process it, the student signs up, and then they write exams, and so you got to generate that page, right? And you're generating it using a template, right? And so in that template, yeah, you pass the information to the template, and the information is there. How many times they taken the exam, whether or not they skipped last time or not.
That's all coming from database.
Yeah. It's not a problem. That's not a problem. Absolutely no problem. That's easy. Trivial, right? He's using this template. Yeah, and yeah, right. And that's just the problem, is right, that the template, you're embedding, you're mixing up the view, which is HTML, and logic, right, with the display, and then it just doesn't have the flexibility that I really needed. And so then you start doing hacks like, okay, instead of saying you can't take it, you just say, well, can you take it, yes or no? And then there's a reason, and then you display the reason, but it was like limitation of the template. Yeah, some background to understand things. So I'm not sure how many people know about servlets. The difference between servlets and the template language is we're going to generate the HTML in code and then display that. Whereas in the template format, you embed code inside HTML, right? It's just the opposite, right? The code generates, and so here's an example where you just output, and you just spit out all the HTML, and there's lots of systems now that do this, right? Now, once you do that right, there's other patterns that come into play. So another problem is a request comes in, right, to your application, and you probably got multiple pages that you need to serve, and so you got to figure out which page does this request want, right? And then you also worry about all kinds of other things, authentication, right? Is this request authorized to go onto this page or not? Maybe you have to log in first, which means every request afterwards, you have to check to see whether or not that session is authorized to go there. There are other problems like cross-scripting problems, right? And so now you want this cross-scripting tag in there that you inject into each page. So when response comes back to you, you can check to see, okay, did this really come from the server before, right? And so there's all these things you want to do. And the page controller is just basically, we get the request. What is the request going to do? Which page you want to go? What model do you want to go here? We're going to go there. And then what data we need over here? What data we need over here? Right. So it's like, okay, is it a get or a post? And then based on that, which view do we use and which model do we use? Right. And so it gets the URL, extracts all the. Usually either there's parameters in URL, or it's a post, and in the body you've got the parameters, and so you extract that information, and you then usually take it and take all those parameters and put them in like a dictionary, so it's easier for the model to grab the data out. And so you just have each page, and you've got a controller for your application, right? And so we have a page controller. But having a separate controller for each page, it can be cumbersome. So then you can have just have one controller for the entire web application. Right. 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 So every request comes through this, right? And then you're going to figure out, okay, again, we have to grab all the data out of it, put it into a dictionary so you can access it, and then say, okay, now, that's that page. So I'm going to call this code to actually handle it. And then you get the result and then return the result, right? And so most of the web applications I built recently have something like this, where there's one site where you say, here's all the URLs I support, and here is the expected data we want. We want these parameters are required, and these are optional. And then here's a function you call to actually then handle that request, and that will return a web page that we send back. It depends upon which one you're talking about. Oh, Eli, that's all the ones on Eli are statically generated. The wiki is written in Smalltalk, and that was done probably 15 years ago by Georgia Tech. The course, the portal, the web portal, again, I did that, and again, that was done over a number of years, probably 15, 20 years ago. And so those do have a strange system to do this, where you have a class that's responsible for the beginning of a web page, and that when you subclass the servlet class, that will then register it as a a site that the controller has to take care of. The newer ones I do closure, and they do a system like this. So literally, it handles that. All requests go to it, and it decodes the request and sends it off to the right place to be handled. It's more complex because you have to handle them all, right? And so usually I find, you go over here, and here's your list of all your URLs, and okay, here's what's going to happen. And then you come over here and handle that particular URL, right? And so there's two places you have to worry about. Another intercepting filter. So there are common operations you want to do. You want logging, so you know what's going on. You may want to do compression. You have to decode and encode data. You want cross-scripting, protection, and you don't want to handle that in every place, right? No, just do it for all of them, right? And so you get this chain or pipeline, and the first part of the pipeline does this filtering. Okay, you do logging, you do cross-script inspection, right? That's all done, and then it gets to your basically page controller, right? And so we're then looking at a pipeline or pipes and filters where you do all this pre and post processing, and you can configure it once, and we're done. And then in your application, you don't worry about cross-site scripting because it's already is in your pipeline to check in advance, and then when you send an answer back, it adds the token, the right token, automatically, and then you can configure the filter. You can configure it independently because, for example, in the other course, right, you don't want necessarily cross-site scripting enabled because then the programmers have to worry about this crazy token they have to store. So you have to turn that off for that part of the website. But so in some sense, an example of just using pipes and filters, right? Um, and then, yeah, the composite view, right, is, often web pages have a certain look and feel, and you got a header, right? And you want all your pages to have the same type of header and maybe a footer, and right, the the site map, and the contact us and about us, and we can use a composite view to compile these things together. Transform view is a different approach. Rather than having a template where you generate and embed your code, or a serverless view where you generate the view, right? Transform view is you have the data and you just do transforms on it, right? So you have a list of exams students can register for. Okay, so what do? We want to write transforms to convert that from XML or JSON into HTML that they can look at, right? And so it's sort of like RxJava, right? Where you have this pipeline and you can do filters and maps and filters and maps and filters and maps, and when you're done, it's like, okay, here's the web page you want to display. And so how do we convert the data, right? Well, we could do it in the objects, but that gets to be sort of awkward. And then you may want to display the same data different ways. Here's a list of exams you could take. Here's exams you have taken. Here's ones you're registered for. And so there's several transform systems that people use. So there's XSLT, which there's this language you can take XML and transform it and output whatever you want. And particularly, you can transform it to to HTML. I've never used a system like that because I was never a fan of XML. It seems awkward and verbose. Right. So have you dealt with XSLT? It's very verbose, and at one time it was a hot topic, so people went nuts and they put it everywhere. No one listened to you. I mean, it's no. But then it's not useful enough, right? Right. Yeah. Yeah. I mean, it's but it's but these are ways in which the web world is taking this idea of the model view controller and trying to wrap their heads around it to make it easier to develop applications. And actually, I think right now the hot one is the Elm architecture with React Native and Elm itself. So far, so good. Okay, some references we'll use later. The last pattern from the Gang of Four, the Facade. Right, yeah. Scale doesn't matter, right? When things get larger, things change, right? What's that?
I said, is that why Texas is so
And to give you some idea of sizes, right? So a jet fighter has 1.7 million lines of code in it, approximately, right? Probably not Fortran, yes. The Boeing 787 has a lot more, and that usually doesn't include the infotainment systems they have now, but that adds a lot. This is just to flying a plane, right? The Chevy Bolt has 10 million lines of embedded code, and it took them 29 months to write it. No, I think it was 2. Right? This is just controlling the car. Well, but you have to, the sensors, these days, cars have thousands of small little, they're not, they're ICUs, right? They're small little chips that have some intelligence, right? They need to be programmed. Mercedes-Benz, with their high-end cars, the radio navigation system just is like 20 million lines of code. There was several places. There was an article in IEEE about cars software. The one about the Chevy Volt was a presentation by engineers that were given, and then that made it to like I got triple E something to, the Mac OS has like an older version, which is, we know this because they released it so people can actually look at it. Premium class, this came from what, an article 10 years ago, had like 100,000 lines of code, 100 million lines of code in it. Debian 4.0 has like almost 300 million lines of code.
So I think are less complex.
But I did have the numbers for more modern, more recent fighter jet, and there was almost, I think, a little bit less than the Boeing. I mean, you don't need a fancy radio. You don't need, I mean, you want things to work, right? And quickly. And one way to make sure things work well is to keep them simple, right? Not make them complicated. Tesla, all the Tesla cars are Linux based. So the Linux computer, which is running the car, maintaining all the systems. And so you've got Linux based, and then you've got all of those embedded processors all over the place that do the control. Plus you have the fancy control system and the fancy radio and the navigation. And all those sensors now for detecting people and cars around you and trying to drive the car. Yeah, right. So when we're talking about size, right? I mean, if you're building a system that's 200 or 300 million lines of code, you're not going to build the same way you build, right? And I read people said, look, there's certain barriers, right? If you don't need to worry architects at all up until about 300 lines of code, then it's like, yeah, we need to do something different, right? And then you figure that out, and then about 20,000 lines of code, again, that process doesn't work anymore. You have to figure out something different because it just gets too big to handle. And there's always these barriers where you have to cross, right? And just for context, right? The textbook for the course has about 8,000 lines of text in it, which means the Chevy Volt is about equivalent to 1,000 books, right? And so the facade pattern is a one pattern in the Gang of Four that talks about scaling. And basically, when you get these big systems, you break them down into components, right? Or subsystems. And then you want to combine these subsystems together, and then you want to sort of hide all the details of those subsystems to make it easier. For one, you've got different teams building each subsystem, right? And so then you need team A to tell you, here's how you interact with a navigation subsystem. And one way to do that is, well, you create a separate class. All it does is an interface to that subsystem.
Your picture looks like interface.
Well, here I'm just saying these are the classes in a single subsystem. You know, what's the proxy doing? Well, the proxy pattern says its goal is to control access to a class. Yeah. And here we're just saying we've got this big, huge, complicated stuff over here, and we don't want that, yeah, abstraction.
Twitter. You don't care about classes.
Yeah, but sometimes those APIs really sort of span multiple subsystems, right? It's like, here's the whole thing. Multiple facades, right? You know, so the goal is to hide that subsystem from other subsystems, keep the subsystem sort of independent as much as possible. And of course, the goal then, you basically want, the textbook says, you know, sometimes you might need to provide one client direct access to a particular piece of the subsystem. You want to avoid that if possible, right? As soon as you do that, then every time you change that piece over here, then it goes over there. And you also want to avoid having the facade add new functionality, because then it gets complicated, because where are the functionalities? Is it here or is it there? And yeah, do you want, again, the goal would be to make all the subsystem classes private and you just go through the facade, right? So one example where I've come across facade is, unlike Java, when you get a Smalltalk implementation, you get the classes for the compiler, and the compiler is written in Smalltalk. And so in VisualWorks, the compiler has 75 classes. I mean, the compiler has to do the parsing, right, and generate the FS syntax tree, and do code generation, and there's all that's very complicated. But what they do is they give you a compiler class, and it's just a facade. And so if you want to use a compiler from inside your code, you just call a compiler class. That's it. And so you can do things like, well, compiler evaluate, and give it and then it does all the things needed. And this example is pretty simple, but we can actually create a method, right? So here's a function, and then I just call method equal to, then I insert the source code and Smalltalk. I mean, they got it backwards. A single quote means it's a string, and a double quote means it's a comment. And so we're creating a string which contains a method, which all it does is has a comment and then sets the count to 0. And now I can get the compiler, and then I can parse this method inside of a particular class. And now that adds that method to the class. Done, right? And we don't have to worry about checking the syntax of it and how to the FS syntax tree and all the complexity and the code generation. The compiler is the interface to that subsystem. Another example of, smaller example, objective C, they've got a number class, and there's different subclasses of number, right? There's char and unsigned char and a bunch of them, right? But they hide that from the programmer. And actually, the documentation doesn't even show that. It just shows a number class. And when you create a number object on an integer, it actually creates a int object, but the return value of the function is just this number, right? And so we don't know all that. We don't have to interact with those systems. It's a much smaller example, and we can argue whether it's a facade or not, but it gives you the basic idea, right? We've got this more complex system, and we're going to hide it from the user. And that's basically the facade, right? And one of the reasons I always postpone this towards the end of the course is, to understand where you might use this, we need to have experience building big things, right? And you don't have time in a single course to build a system big enough to need a facade. Yeah. Yeah, it's paper note, it's the wrapper, right?
Reduces. Still use it.
Yeah, we don't need to even pick on Fortran, right?
Really, that's
Yeah,
an example where
right.
it's like, it's
You have a
essentially language proven it produces
fact,
result.
but we also have large code bases of C and COBOL, and right. And the problem is, once you've invested N years of M developer time, right, developing this code base, you're not going to rewrite it. Because every time you do, it's a nightmare. And so then what do? I mean, you have to keep it running, and programmers don't want to learn Fortran or COBOL or C or. And so you write a wrap around it, and you get things like the air traffic control system that's written on mainframes, which haven't been produced for years. So far, so good. A slight break from patterns. Another common rule of thumb for writing good code, the law of Demeter. And so the official statement of the law of Demeter is, so you have some method, right? M in the class, an object O or class O. It can only call methods on the following types of things. O itself, right? I mean, so you can call all the methods in that class. Any argument you pass into that, right? Any object you create inside M, you can then interact with. Any fields inside of M, you can interact with them. And any sort of global variable. Right? So this is the formal statement of law of Demeter. Yes.
Excluding like the private member.
So we can also sort of rephrase it to you only get one dot.
So don't change.
So this right works, right? What about that? No, because you're violating the law of Demeter because now you're going inside of. So A is either going to be a field or it's going to be an argument or something you created, but B is not any of those, right? And then you're calling a method. What's that? It's done everywhere, right? Okay, so the question is, what is the law of Demeter trying to prevent us from doing, and why is that going to be beneficial, right? So what does this do for us? Well, one as a developer, when you come across this, what is B? You don't know, right? So what do you have to do? You have to find out what A is, and then go to the definition of A, and then see what B is to figure out what you're dealing with, right? And so that's sort of irritating. The second thing is when we talk about coupling and cohesion, right? Now the method we're in, we know it's coupled to A, whatever class A is, because we're dealing with A, but from the outside, we're not going to see that it's also coupled with B, right? So we've got this hidden coupling, and so if we start mucking with B, we then have to find all the places where we do this, right?
It has a property array,
right?
And if you want to access .count to that array through an object, a.array.count. So instead of doing that, all the array properties in class A.
Well, so then we can talk about, right, the Dilbert principle, right? Where the Dilbert principle say, I mean, you don't want, I mean, don't do all the work. Let someone else do it, right? So then you say, okay, we should have A. We're doing this for to get something done, right? So tell A to do it, right? Now, in your case, you probably don't need all the properties of the array, right? What do you want to do with that array? Then there's this, right? Where you call a function and a method and you call another method. And the same problem is what does method B return? And then we're coupled to whatever that is. So yeah, this violates the law of Demeter. Again, we can do this. This is slightly better in the sense of now to declare foo, at least in Java, we know what type it is. And so now at least we know what we're dealing with as opposed to hiding it with a chain method. But again, we're getting this hidden coupling between whatever foo is. And so that violates the law of Demeter. And so the law of Demeter is trying to reduce all this hidden coupling we produce and trying to get us to follow the Dilbert principle and just saying, okay, I need this from you. Do it, right? Whatever that means. And it comes from Indiana University, where they noticed that code that followed this was so easier to read and understand and maintain. Now there is, what's that?
Constructing.
Like this, right? So what about this example, right? Where, it's a builder example where you're new notification builder, then do this, do this, do this, right? But in that builder pattern, each function returns the same object, right? When we went too far. So each of those set methods returns the notification object or builder object. Right, so we're still dealing with, we're creating the builder here, and then each one of those methods is on the builder. Right? Yeah, it's just, instead of saying builder equals this, and then this on the builder, this on the builder, this on the builder, it's dot, 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 and it's all these methods are going to the builder. Right. And so, yeah, each method returns a builder, and so we could do it this way, right? And then we're explicitly satisfying the law of Demeter, but it gets painful to do that, right? More wall of text. You don't gain anything and actually lose something, because when you do this, it's clear that it's all going, it's all happening on that object, yeah. As opposed to, I'll have to check, the receiver each time. All these design patterns allow us to make our software more flexible in certain ways, right? So, one analogy I use, like hinges, right? So we want a door, and we want to close the door and open the door. And so, okay, we use hinges, that gives us some flexibility. Same thing in software. And so then you have to ask yourself, where do we need that flexibility? And each time we use a design pattern, it adds more flexible point, but it also adds more complexity, right? To make it, it's building a wall is pretty straightforward, right? But now you put a door in there. Now we need, we have to put the frame. We have to make sure that we don't need support right in that part of the building, and right, and then we need all that. It'd be cheaper and simpler just as like one big wall, right? And that's the same thing happening with software. So we need this. But one of the things I find is that when we talk about software, it's usually we'll talk about the context, right? So it's pretty rare we write software which doesn't talk to a database of some sort, right? Pretty much every web page is just an interface to a database, right? Amazon pages, Amazon is just one big catalog, right? Stored in a database, and you're just, all their website is just a way of making your way through that big, huge database. And then when you're submitting orders, just submitting it to a different database to keep track of all their orders, right? Even Google, right? You go and do the search in Google, it's like, there's there are these huge, huge rooms of just machines that contain untold amount of data. You're just like, okay, find me that one piece I want, right? And so if you don't talk about how you talk to a database and incorporate that into your application, we haven't talked about software development, right? Because it's pretty rare. Another story we haven't talked about is, well, look, it was Cyber Monday, right? And before that, it was Black Friday. And so there's all these deals, right? Buy 2 and get 1 for half price. Buy 3 and get the 4th one free. And it used to be done for 1 day, but now it's done for a week, right? But it's still just done for a short period of time. And there was one time when Starbucks closed down all their stores for 1 day for some training, and then Dunkin' Donuts said, come to us and we'll sell you a coffee for a dime. But, how do you, so the software, it's all driven by software, right? So you have to be able to write your software so that we can do that, right? So, someone Dunkin' Donuts hears that, next week, Starbucks is shutting down for a day. We want to do something. Okay. So next Tuesday, you programmer make sure that every Dunkin' Donuts store can sell coffee for a dime. And the answer is not going to be compiling code and shipping it out to all the stores, right? It's not going to be the answer. It's not going to work, right? So how do we make these business rules so that we can change them on the fly, basically? And so I want to talk about a few patterns, talk about this. But one of the basic answers is we need to push that stuff to the data, right? So like business rules shouldn't be in code, they should be in data. And then our code reads those rules and runs it so that, when he's told next Tuesday coffee costs a dime, he changes the data, right? And that can be pushed out to all stores easily. Well, so if you haven't planned for an event, you're dead, right? Your software has to be written so that, right, the business rules are in our data, not code, right?
So that way, literally, it's okay for iPads.
Right, right. Well, so these days, oh, no. They still should have the old backup way of doing it. At least some stores do, right? Where you have the card and you go, and you get paper, and then you send the paper in. but also, right, these stores now, the old cash registers used to be just a mount, right? You type in $10.32 and then plus this, plus that. But these days, no, it's like a hamburger, fries, a large Coke, a small Coke, right? And so you got this big pad that contains the items people are buying. At a fast food place, at a place like Sears, right? You scanned it in, right? And then it records what the item is. And so those cash registers at the fast food places have to be programmed on which items are displayed and what the prices are, because you just press, cappuccino with this, right? And then it knows how much that is. And retail stores, when you scan it in, that comes from a database, presumably a local copy, because networks do go down.
The database, price.
Well, I don't know what Dunkin' Donuts, how their software works, right? The question is, what sort of techniques can we use to achieve that? And so one thing you know about is metaprogramming. And this is where being a Java programmer puts you at a great disadvantage. Well, C++ is even worse. So you're not going to do this in C++. Right. So the idea here is we can, write programs that basically write programs, or take data in and convert them to programs and run that code. Right. And C++ is going to be painful, right? Even in Java, it can be done, but it's very, very painful. For one is, the compiler's not there. Python, Bash. Smalltalk's good at it because you can actually just literally, like I showed you, just say compiler evaluate, right, and give it a string, and then it executes it. Lisp is very good at it, is standard, because a Lisp program is just data, right? Lisp programs are only data, and so you can take it and manipulate the program you're in, or you can generate your own program and just eval on it. So we want some patterns which help us do this. And one of the papers this comes from says, yeah, the problem is, the forces act on software development. Typically, we want to make things more and more. We get it working, and we have features more general. The more general, the better, right? But the more general, it's harder to deal with. And so to do that, to be more general, we push things out into data, right? Business, how do we do price of coffee? Oh, everything is put business rules in the data so that when we want to change them, right, we can. And it makes itself more general because now we can now modify our business rules on the fly. So next time we'll look at the property pattern and how to use that to make software far more general, but harder to understand.